Hey everybody, this is Larry. This is me going with Q2 of the weekly contest 413. Select cells in grid with maximum score. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one I actually did a couple of optimizations, so let me double check real quick. What is this again? Select cells in grid with maximum whatever. So this mine went too very fast, but I don't know if all of it is necessary. So there may be some other things, and I end up taking a little bit more time than I needed. Yeah, maybe the script been a little bit faster, but it's fine. Anyway, there are this is one of those problems that if you have enough experience, if you have enough practice, you'll recognize that this is kind of a very hard problem. And I don't mean hard as in difficult, even though it is as well, but I mean hard as in complex theory of computationally complexity hard, right? I don't know if it's NP, maybe it is an NP, but like you probably could reduce this to one of those NP problems. But yeah, with experience, you're able to kind of have a feel for it. So what that means is that you have to look at the constraints, is what I was going to say. And the constraints are kind of interesting, right? It allows you to kind of do, think about things in a way. Because 10 by 10 is okay. Maybe that's interesting, maybe not. But the other thing is also grid of ij is less than or equal to 100, also maybe interesting. I think a combination of those two are what I'm going to use here, right? So basically, one thing I would say is that because no two selected cell in the same row, you can basically look at each row as being used once, right? Okay, so that's the first thing I did, is that, and if you think about that, and if you think about it in a Bitmask kind of way, I'll go over Bitmask in a very intro kind of way, but I don't want to spend too much time on it, just because we have a lot to get through for this one and maybe Q4. But the idea with Bitmask is just that you just have an array of every possibility of whether a row is used or not, and the 2 to the 10 number of ways that happens, right? Okay. And then the next thing is that if you are going to use a row, and I guess you don't technically need to impose this ordering, but I do anyway, right? Which is that, and maybe this is one of the extra optimizations, but is that if you are to use a row currently, you want to take the maximum value that you can, right? Because it doesn't make sense. If you're going to burn a row, it doesn't make sense to take a less than one. And there is a more precise way of thinking about this, so we have to think about it. And then the other thing is that the values in the selected cells are unique. There are ways to think about this, and of course, this is what makes the problem tricky. Otherwise, you just kind of, it's a for loop and take the max, right? So this part is the tricky part for sure, or one of the complications about this part, right? So the way that I end up doing is that, okay, like I said, so yeah, some key ideas is that we can, how do you say, keep track of, so these are the states, right? So we can use as a state whether we used each row, right? Or so there are 10, I don't know why I wrote 2, 10 rows, so that means that there's 2 to the 10 possibilities, right? And then the other, which is that as a you can impose an ordering, right? Then now, and so you can. And what I mean by that is that it is going to be the previous score that we took. And here, how do we, one thing about this uniqueness is that if you're not careful, if you don't know how to do it, which I didn't for a while, right? Is that if it's unique, then you have to keep track of every number that you took, right? But if you take the number in a decreasing order or increasing order, I suppose it doesn't, whichever way, but I did it in a decreasing way. If you take the numbers in a decreasing order, then now you only need to know the last number, because every number before that is going to be bigger, and every number that you're going to take in the future is smaller, so there will be no overlap, right? So yeah, and in this case, they're only, because the grid sub ij is only up to 100, the max value is 100, so there are 100 possibilities. And that's really basically the idea behind this problem, and these are the states. And with this idea, for each state, we want to just brute force or enumerate or taking the max value from each row, or max value from each row, max value that is lower than the previous value. Previous value, I guess, it's not score. Sorry, from each row, and then take the best of them, right? So that's basically what I have here in the implementation. I have a lot of spacing here for some reason. Okay, let's get rid of some of this, right? I actually end up doing a lookup thing as a result. So, okay, let's go over the actual implementation, right? So here we just define the things. This is the, I don't know why this is here. Oh, maybe I thought about writing it a different way, but so that's actually not necessary. Actually, maybe a little bit confusing. But okay, so here we want to sort. The way that I did it is that I sort each row in decreasing order. It allows us to do binary search, which I think you can do as well to get the next number, but I actually even just create a lookup table, right? So what does this lookup table do? I don't know that this is necessary, but this is what I do. So, which is that lookup sub ik in my example is that for row I and the max y for row I, lookup sub ik contains the column, the first column that is smaller than k, right? So basically what this does is that, for example, if k is 5, then we want to get the next column, or the first column, that has a 4 or a 3 or a 2 or 1, so the next number in the list that we can possibly go to. And the way that I think about it now, actually, you can just do a grid of ij. We don't even need to do the index, but maybe we'll do it later. I'm kind of confusing y'all with my optimizations, but it's not even that big of an optimization, right? So yeah, so then here we have this thing, right? So we have used, it's a Bitmask of the rows we've used so far. Last is the last value we added on this score on the list or whatever, and count is just the number of rows used. I guess technically it's not even necessary. I mean, this does not complicate things because count can be calculated from used. I just kind of did it so that I could have this if statement, but now that I think about it, I don't even need it because it would just, this would just loop through and then just return 0. So let's make it slightly less complex by removing it, because I think I just maybe made it a little bit more confusing as a result for y'all. 8 and 15. Let's submit it just to make sure we're still right and I'm not lying to you. Okay, looks good, right? And is it faster? Let me also check real quick. About the same time. But yeah. Okay. But yeah, so we don't even have count anymore, right? And a short, for this problem, you need to know Bitmask. I've talked about this in other videos, so I'm not going to go over it in depth. But the idea behind a Bitmask is that you can think about this as a Boolean array of whether a row is used, because the reason is because a binary array or binary number, you can think of it as like ones and zeros. So that means that a 1 means, I think, a 1 means that row is used. A 0 means that it is not used. I'm not going to go over that detail in this video. My apologies. Maybe I need to do a specific video because people keep asking me, but I don't want to do it on every video, you know. But yeah, so that's basically Bitmask, right? And here we just try every row, right? Try every row that is not used, and that's basically what we have here. If it's already used, then here we get the next the biggest value we can use from this row, which index allow us to get that index, and of course we make sure that the index is I actually think I default everything to C, which means that is out of bounds. So if this is out of bounds, that means that there are no numbers in that value. But if there is, then the score is equal to, okay, we mark this as being used, this row is being used, this is now the biggest number or the last number that you add on the list, and then you add this as the score. And if the score is bigger than best, best is equal to score, right? Because that's just updating it in a greedy way. And now we can return best, and that's pretty much it. And what's the complexity here, right? Well, total complexity is always going to be equal to total number of inputs times time per input, and yeah, number of inputs is equal to as I said, use is going to be 2 to the 10 or 2 to the R, if you want to call it that. Last is going to be let's just say B for range. Why do I use B for range? I don't know. B for range, a number of bits, maybe, I guess, kind of. It's not quite, but B for range, which in this case is 100, right? So that means, and for each one, we do O of R work. So, okay, wait. Number of inputs is 2 to the R times B, and each input, we do O of R work to, if nothing else, just to check if it's used, right? So that means that total time is going to be O of 2 to the R times B times R, right? And of course, if you do the math, this is like 1024, I know. 1,000 times B, was B again? 100. So 100,000 times R is 10, right? Oh, wait. Yeah. So that's like 1,000,000, right? So that's going to be fast enough, as you see. Yeah, and not all of them are possible as well either, because last doesn't, it's not every last is possible because it has to be used or something like this. So yeah, but that's the basic time. Total space is the same idea, except for we have O of 1 work, so it's going to be 2 to the R time, so 2 to the R times B space, and that's all we have for this one. So I did say that you don't need this lookup, because basically after we sort this, right? After we sort this, we get the biggest value that we can use in this row. We can actually use binary search here as well. Would it change the complexity? I guess a little bit, because it changed from R to R times or each input does R times log C work. So this adds a log C component, which seems like it shouldn't matter because it's log 10, right? But I didn't want to deal with it, so that's why I kind of did it this way. And you can see that I actually do this thing. So you can actually optimize this a little bit by having the lookup store the value itself. So instead of like grid I of index, this would already store grid of I of j or something like this, right? So you could do something like this as an optimization if you like. Then now, value is equal to this, right? And yeah, and of course here maybe you would have negative infinity here instead. So something like that. Maybe that's wrong. I don't know. Oh, index is, because index is a function name. That's why it's a little bit weird. Oh, well, yeah, I guess we don't need that, but, oh, because this is now negative infinity. Okay, well, yeah, fine. No, not a big deal, just like minor cleanup, assuming this, But yeah, so you can definitely do it this way as well with the lookup. Like I said, you could do binary search. I'm not going to do that here. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and let me show you all the code all together. Here, the one with my notes. Here's the top with the lookup and the sorting. I guess I didn't add the sorting and the complexity, but this gets dominated. That's why I didn't talk about it. This as well, because it also gets dominated by this, so that's why I didn't talk about it. Because this is R times B, which gets dominated by 2 times R times B, right? Maybe you could write R times B, I guess technically. I don't know. Yeah. And anyway, and here's the rest of the code. Very straightforward. I mean, I had like so many comments that like the code is actually like 5 lines of code or whatever, right? For the DP function. And yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you could watch me solve a live in contest now. The values of this. So just one from each row, right? 10 by 10. One from each row, so it's either 878 or 878. This is a hard problem. Can anyone solve this one? No. Ten by 10. Well, there are only 9 numbers, but is it always possible? I guess it's no. No, I guess it's always possible because you don't need to. You could have more rows than columns. Okay. You don't need to select from every row. Is it sorting? Is it greedy? How do you choose for example, how do you choose which one to go? No one's gotten it yet, which is, I guess, good. Okay, so 10 by 10. So the answer is at most 1,000. Less than that, really, but can I? The uniqueness is kind of weird. Okay, let's say they're all identical, right? Then now it's going to choose one. That means by definition we've okay. So okay. The row thing is a confusing thing. So it's a DP on. Is it a DP, Larry? Okay, and reverse. Okay, so then now we want to okay, there's a Bitmask for each row. And a maximum value that the last value, and we select from that, right? It's a little bit wonky, but $100 times 1,000 should be fine, but we have to be careful about this one, I think. Do like a reverse binary search or something. I want to do a lookup. That's what I want to do. Okay, fine. So then now for each row we have a lookup. Okay. Now for people guys so far, 6 people. I think I'm on the right track. We'll see. So that now no. We want to see for k in range of 1. We want to see the next number or the first index in which it is bigger than this one, right? If grid of I k is so if if the max is this, we want to see the next number that is smaller than it. So if, this is if this number is no, sorry, yeah. So okay. What? Okay, this is right. So then now if we have 0, if 0 is the max, then 2 is the max, then we get, okay. What? 4 is the, okay, yeah, I think this is right. It's so easy to get off by 1 is why. Okay, so then now we want index 0 local. Oops. Okay, right. I need 101. Okay, and then now it is present. Last is going to be quit sub I of index. This our bound over. Oh, because this is n. Yeah, okay. Yeah. Eight and 15. I want to make sure that we. Looks okay. Is it fast enough? I don't know. Let's try a real quick one. Oh, this is definitely wrong because oh no, I do keep track of here, so I think that's right. Okay, fine. I know I'm spending time on this. I probably don't need to. I probably should YOLO this, but I just want to see about the timing. That's not a great sign though. Oh no, it's 10 by 10, not 100 by 100. So, okay, so maybe it still could be a good sign, but let's see. Okay, yeah, that's fast enough for 10 by 10. Okay. YOLO. Okay, thank you, sir. 25 people got it. How many people got this? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest or this problem or everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.